The microphone is mute, sir. Good morning, sir. The microphone is mute, sir.
So let me start all over again. I told you that before now we have, please switch off your mics or mute yourself. I told you that there are energy storage elements in electric circuit, and this energy storage element, their responsibility is to store charges and to give out charges when it is needed. And I will tell you why you need to store charges and when you need why you need to give it out. But however, let me introduce you to the energy storage element. There are two types of circuit elements. We have the active elements and we have the passive elements. The active elements, most of the time, they serve as the independent source of energy to the rest of the network or the circuit. While the passive element, in a number of times, they depend on the. Please, I will read. Who is this now? What kind of thing is this? Please don't put on your mic. I've said this over and over again. So the active element, as I said, they are independent of any other elements. They can supply power to the system or current to the system in order to run the system. Whereas the passive element, on the other hand, they dissipate the energy in the circuit. So they are the active element and those elements that can supply energy. So on the account of that, there are energy storage elements in every circuit. Capacitors and inductors especially. While capacitor stores energy in form of electric field, inductor stores its own in form of magnetic field. And then as passive element, they can store energy supplied by circuit. They can return stored energy to the circuit and cannot supply energy to circuit more than is stored. Whatever is stored in them is what they can give out. So this is a good example of how a passive element looks. This is a very good example of it, whereby when it is for, if you look at those both sides, you will see inductor on the left and you will see the capacitor on the right. Then when it is when it's releasing energy to the rest of the circuit, you have the blue line or the blue arrow. And when it's drawing energy from the circuit, that is for inductor, you have the red line. When it is releasing energy to the circuit, you see the blue line. And when it is drawing energy from the circuit, you see the red line. And the same way with the capacitor, when it's releasing energy to the circuit, you have the blue line. And then when it's drawing energy from the rest of the circuit, you have the blue line. Or the red line, sorry. So on the account, I have taken you through VI characteristics of a circuit element. Is also applicable in this case. VI characteristics of a circuit without energy storage element is always linear. So without the energy storage element, it's always linear. VI characteristics of circuit with energy storage, we usually give a constant derivative of either differential or integral equation. Capacitor as a storage element is normally used for modeling computer and other electronic loads. So you find it in many computers and other electronic loads, and they are used as power supply. Inductor, on the other hand, as a storage element, is employed in electric motors. It is employed in electric motors. Both capacitor and inductors are used for building filters and amplifiers, and you are desire for your desired frequency because of the fact that they have omega. Omega is 2 pi f. So with that, you can use them to build filters and amplifiers. Oh, sorry, it's going back. So on that note, you have the capacitance of a circuit. I've taught you about capacitance of a circuit when we were looking at circuit elements in parallel and in series. So I don't think I need to overflog this. I said that the opposite charges on the two plates create an electric field that is stored that is stored as energy between the two plates. And we have mathematically Q equals to CV, where Q is your charge, C is the capacitance, and V is the voltage. So the rest of the circuit with the capacitor is as shown in this particular circuit diagram. And you can see the mathematical expression as well. I of t is equal to C dV dt. Using the circuit diagram in the previous slide, we can go further from I C dV dt to get V of t to be 1 over C integral of I dx, or I dt, sorry, I dt. So on that account, you have what we have, that is V of t is equal to V of t naught, that's initial, and then the other part is as shown in the diagram. So energy stored in the circuit is W, which is equal to half CV squared. So if you are to calculate, looking at this particular, you have to calculate here V of t and W of t in this circuit. When you go about it, you just use the formula that I have supplied here. That's once you have your current, you can do that without any. So inductance, on the other hand, is the outcome of the flow of current through a real conductor. Whenever current flows through a conductor, it leads to excitation of magnetic field in the conductor. The rate of change of the magnetic field gives the voltage difference in the circuit. This you already know from your elementary physics. So inductance is L, which is equals to voltage times second all over ampere. That's using the dimension. So in the same vein, you can have the rest of the circuit, and you have the inductor connected in this fashion. And in that case, V of t will be equal to L di dt, which you know very well. And then where I is the current flow, L is the inductance, and V is the voltage. So to calculate the inductor current, you have this kind of, remember that in the case of voltage, what we calculated was not current. Let me take you back. We calculated voltage of the stored between the capacitor plates. But when we are looking at inductor now, we said we have to calculate current that is flowing across the inductor, because the current is what we store the energy in the inductor as it's pumping it. So we have 1 over L integral from infinity to t V of t dt. And then I of t is equal to I of t naught plus 1 over L from t naught to t. So you have that. And then when you are looking for the energy stored in the inductor, you have omega W equals to half L I squared. I have given you this before. I've done this under circuit elements connected in series and in parallel. So when you are talking of series connection, you have the first mathematical expression. When you are talking of parallel connection, you have the second expression. The same thing with the inductor, series connected inductors. You can see the way you bring them together, while parallel connected inductors are assumed as well. This one we have done, and we have treated it elaborately in our previous lecture. So this is the connection, which we have done before anyway. This is the connection for series, for parallel. You can see that we have C equivalent here. That's adding everything together for series. C equivalent here, adding all together for parallel. Then for inductor, you have the same approach as well, because it is the current that is the element that is flowing here. You have to use current to commence your equation so that you don't miss out anything. So the same thing with the series connected inductor. You can see how the voltages are handled. So we have as well this kind of expression for the equivalent inductance. So all this one we've done before, so I don't need to take too much of time there. So to find the analysis of an inductor in parallel, you have this kind of arrangement where you have I1, I2, and I3 for different branches. And then what happens to it thereafter? You add in this form, and you get your result in this form. So likewise for capacitor, for inductors. So the equivalent inductance is as given here when everything has been combined together. So we want to move to the main reason why this topic is being brought up, which is the storage element. I've told you that the storage elements in the electric circuits are capacitors and inductors. And then we want to look at how we can use them. When you are trying to close an open circuit and you toggle the switch as you see it, with that arrow going down means that the circuit is about to be closed. If you close that circuit for the first diagram, we are told that in this circuit, the voltage, the, 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 the current will flow across that switch once the switch is closed, and the charges will begin to build up between the two plates of capacitor, as we have said before. And as it grows, you are going to have an expression which we will explain later. Likewise, if you look at the inductor, you will see that the inductor was connected first to a source of supply. The source of supply is ready. By the time you move the arrow to the opening there, you find out that the circuit is closed and the current can flow from the source through the inductor. And as you do this as well, current will begin to, as current flows, charges will begin to be built up within the inductor, which will lead to a VL. So if the source cannot produce infinite instant power, then neither the capacitor voltage nor the inductor current can change instantaneously. So if there is no way that the source can provide instantaneous power, then the capacitor voltage and the current, inductor current, can change simultaneously, instantaneously. So the DC analysis of the circuit only provides a description of voltage and current in steady state. When the applied voltage or current changes at some time, say T naught, a transient response is produced that dies out over a period of time, leaving a new steady state behavior. The circuit's differential equation must be used to determine complete voltage and current responses. So we have a way of carrying out this. When you have a DC source, after the switch has been closed, transient part have same form as the natural response. And then we use the steady state response and the initial condition to determine the constant. So that is what we do in this case. So I will take you through this. This is a typical work. In this place, we are to describe V naught for all T. And we are to identify transient and steady state response. So you can see when the arrow, the switch close to the DC battery or DC voltage, if it is closed, current will flow from that place even through the resistor rather, and the capacitor. But no current will flow in that branch that is parallel to the battery. So you can write your V naught of T as written in this place. For T greater or equals to 0, and for T less than 0, it will be 0 volts. It will be 0 volts, obviously, because no voltage has dropped before the switch was closed. And before the switch was closed, is T less than 0. So please take note of that. Then we have another circuit of this nature, in which case we have the RLC circuit. When the switch has been closed for a long time, the initial condition will be I of 0 will be equal to 0 amp, while VC of 0 will be equal to 45 volt. And the steady state condition, that is when I is infinity, it has been on for so long, you have current as 0, and you have the VC as 120 volts. So please, let's take note of all this. You can work all this out to get the answer. So on the account of that, you can calculate alpha, which is R over 2L, while you can calculate omega naught square, which is 1 over LC. And you will get the two constant, alpha 1 and alpha 2, which is as calculated. And by the time you slot it into that VC of T, you have this equation on the slide. I will still take you through the rudiments of this by our next lecture. I just want to bring you to them on how this is useful. So likewise, we have I naught of T at this, which is equals to 0 at I naught at 0 time equals to 0. So you have this description, and you can as well have this equation so that you can get to K2 and K1. So by using MATLAB, you can get your the behavior of that particular circuit, the voltage in that particular circuit. You can get the behavior in this form. So in order to denote the time right before T equals to 0, that is limit from the left as T turns to 0, and the time right after T equals to 0, that is limit from the right as T it approaches 0. For the circuit with practical source, the voltage across the capacitor cannot change instantaneously. So it will take some time for the voltage across a capacitor to change. So that's why when you draw it, we see that at the beginning, you don't see any variation with time, but with little time, again, variation will begin to be noticeable. And the same thing with the inductor. In this case, the current in an inductor cannot change instantaneously. So you can still have this kind of arrangement. And let me quickly say something. You can have this kind of arrangement. But let me quickly say something. When you have a source that is supplying your circuit, we call it a natural response. When you have to use an external energy to power your circuit, we call it, no, natural is the one that is powering itself, supplying this energy either through a stored energy in an inductor or capacitor. And the first is the one that has an external source of supply that is independent of whatever you have in the circuit. So I think I need to make that clarification. So you have this as well, and you can calculate alpha 1 and alpha 2 as it is done here. So this will give you this description here. And then for RLC circuit, when you talk of RLC circuit, you have this kind of arrangement. And then you can get the equation this way. So this, what I have done today is to run you through what we will do in the few weeks that is ahead of us. Because I know that some people are just joining us. So probably what I will do is that I will break for now. And by next week, we will carry out a review of all that we have done in the previous lectures. And then after the preview of all that we have done in the previous lecture, we'll be able to now go into this particular energy storage element fully. So I don't know if any one of you have questions, ask questions or questions.
Yes, I
But
have, sir. Good morning, sir.
Yeah, go on.
My question is in the formula you gave in the alpha and omega. I don't know the difference. Is there any difference between the two?
For which one?
You in the previous slide, I think the two slide backward, you showed alpha and omega. Then what does the alpha means there? What's it used for there?
Let me.
Okay. Okay.
Am I going towards it?
Yes,
Or
no, you are getting there, sir. It's still back. It's at the back. Yes, sir. It's okay here.
Okay.
So the alpha here, I don't know what
Yes.
it stands for.
The alpha, you see, when you are writing your equation,
Okay,
that's
sir.
why I said I'm just opening it up. I will still go to the stage by stage appreciation of it, but I just want you to know what to expect in the
Okay, sir.
next few lectures that we have. Alpha is when you take a frequency domain network, you will have what we call alpha plus j omega. That is S equals to alpha plus j omega. And alpha there is the real part, while omega is the imaginary part. And so alpha, there is a way we calculate it, which I have not shown to you, which I think we will show in the subsequent lectures. But if you look at the formula, you will see that the formulas are different. So the alpha serve, and that, why do you need alpha? You need it because of the equation you are writing here. Because of this equation, you will need alpha there, which is there. And then if you look at the previous one as well, I think that's not the only place I mentioned it. I think I gave you the formula somewhere there. I gave the formula somewhere here.
5 over
Yeah.
5 over L. 5 over 2. Here, R over 2L.
Yes. Yes. So on the account of this, if you look at it critically, you will see that alpha, by the time we resolve it further, we are able to get, when R over 2L, when you get it, it is 100, and omega square is 1 over LC. On the account of this, these are the standard formula for this. See that? These are the standard formula for this. And by the time you are trying to get A1 and A2, which are your value for the exponential,
Okay.
you will have to bring in the alpha and the omega.
Omega.
That's how we use it to calculate A1 and A2. But for now, I'm just trying to pass you through what we have so that by the time I settle down to the lecture, I can easily make reference to this and you can see how we use it.
All right. Thank you, sir.
Okay. So another essence of this meeting is that I want to believe everyone has done his or her lab, except the people that are outside Lagos, especially those from the southwest, south, as well as the north part of the south, southeast, and those from the northern part of the country. With the exception of that, we expect that you will have done your lab by now. And it is discovered that quite a number of you have not been taking the lab very serious because you just come at any time to the lab. It's not the best for you. That's number one. Number two, I need to make it known to you that you are supposed to dress in a respectable manner. You cannot come to the lab with a slippers or without your feet being fully covered. So I appeal to you that when you are coming to the lab next time, or whoever is coming, please make sure you dress well, because I will begin to send people out in this second batch or second tranche of the laboratory work, having given that privilege to you before now that because you were not told officially, we will not put up any form of punitive measure. But now, thereafter, we have to go to that. So please, when you are coming to lab, there will be lab on Wednesday, there will be lab on Thursday and Friday. And I want to believe we will conclude the lab by then. So please make yourself available. Make yourself available. But for any reason, those who are not within Lagos, we are giving you that privilege that you will come back later. When you resume for the physical lecture, you'll be allowed to take your lecture, to take your labs. But we will need evidence. As I have said before, we will need evidence. And the evidence that I will take from you is about data, which is what you will generate for me to say, truly, I don't live around Lagos and I don't live in the Southwest. Anyone living in the Southwest should be able to come for the lab. It is the South, Southeast, and the Northern guys who do not have any relationship with Lagos. They just came to Lagos for academic purpose. They are the only people that will be granted that privilege of coming for during the physical part of your semester, which I call residential. During the residential period, they will be permitted to do their labs. And as I always tell you, by the time you are resuming back, you will be having tests back to back. So why don't you do your lab now and take it out of your responsibilities so that when you come, you just know that you are facing only exams and tests. So please, tomorrow, make yourself available. Thursday, make yourself available. And Friday, make yourself available. We'll be there waiting for you. Thank you.
Sir,
Yeah.
in the list that you dropped, some people name are not there in the EEG lab. So
And that means that means they have not registered. If you have paid your school fees, if you have paid your school fees and you have registered, there shouldn't be any reason why your name should not be there.
let's say
However, if your name, okay, I'm listening to you.
If they paid later, like the later paid, as at the time you drop it, their name is not there, but the later paid now, and there's no new list.
I just extracted that list from CITS, I think last week, Monday. Last week, Monday is when I extracted that list from CITS. So how somebody would not have paid by then, they should have let me know. Because by now, I believe all the direct entry students have already been screened. So there shouldn't be any screening still going on. That's why I waited till that time. However, if there is anybody whose name is not on that list, let such write to me, because I will need to compile the list and send it to the CITS that they should help me check out. If I don't receive any mail from you, I then forget about it.
Okay, sir.
But whatever I receive from you is what I will communicate with the CITS, because by CITS information to me, they have done the last batch of our extraction of the list for the laboratory. But if there are people now whose name have not been featured, then a letter is needed so that I can forward it to the CITS for them to help me harvest the list again. Maybe their names were, they escaped their names or things of that nature. And I should have that latest by Thursday so that by Friday I can communicate it.
Okay, sir.
They don't need to bring it individually. Submit it to your course rep. Submit it to your course rep. The course rep will compile and send to me. So what the course rep will do for me is that they will scan all the individual letters and put them in a thread, not individually. They will put them in a thread that they will flow as one link, one connected list of papers. So it's not that you will just do it one after the other, but you will do it as a thread that they will follow each other in a vertical mode. That if I'm scrolling down, I will be able to scroll through each and every one of them. If you can send that to me, let me have it by Thursday, latest by 12 noon on Thursday. Submit
sir,
it to your classroom.
Hello, sir.
Yes.
Another thing is, if the person name is not there and the person is available, can the person still go and do the lab and still submit to you that his or her name is not there?
No,
And,
you can't do that without your name on that list. To us, once your name is not on that list, you have not paid. So you are not our student by any chance. You are not our student by any chance. You cannot do lab without your name without being registered by CITS. That's breaking the university rule.
All right, sir.
We will not allow you to do lab. You wait until you pay and until we can ascertain that you have been registered, you have registered for the course. I can see two other hands up. Okay, is it the same thing? Okay, So we close the lecture at this
Sir,
stage. We close the lecture at this stage and then see you next week.
sir,
Yeah.
sir, can we get the list, the new list, sir, so you can see if our name is there?
Get which list?
The You said you were going to print a new set of people for the people that
I'm
just
not
paid.
giving it. I'm not giving it to the student. Go and check it. They have already done a schedule on the notice board. Go and check there and see whether your name is there or not.
So sorry, sir, on what notice board, sir?
At the lab, we have a notice
Okay,
board by the lab.
okay, sir, I'll check.
Uh,
Those of us that
by
live
the lab.
outside Lagos and still want to go, just go and check. And
Maybe you have friends who can check for you. If you are from Southwest, you are not granted the permission not to come and do your lab. The guys, you can travel anywhere. If you are from Southwest, you can travel to your station after the lab. If you come early, we do it in such a way that if you come early, by 12, you will be through with your lab and you return to your station. So nobody from Southwest will come and tell me any story. If you are from Southeast, Southwest, South, and North, those are the people I'm giving that privilege. But if you are from Southwest and you don't do your lab, you are on your own. No. You are on your own.
sir, the issue is, how do we know if our name is going to be there? Like, if I'm coming
Tell
from
your
Ibadan,
colleagues to check for you, my friend. Maybe you have classmates. That's
Sir,
not, you don't need rocket science to know now.
good morning, sir. Good
Yeah.
morning, sir. Sir, please, my question is for those in Southwest, is this week, Wednesday, Thursday, Friday, the deadline for us to do the lab, or there will still be like other period before?
Anybody whose name is not on that list and does not do it this week, when we schedule them, should forget about it. It's coming back for it next year, especially those from the Southwest. The Southeast, the South, and North, you will show me your biodata. I will see there that where you live, where you give as your address is either Port Harcourt, Warri, Minna, Abuja, or even Kano. Without seeing that on your biodata, forget about it. You will come back next year.
Sir, morning, sir.
Yeah.
Please, some of us just got admitted last week, Tuesday. Is there a possibility that our name will be on the list?
Tell your colleagues to check for you if you are not in Lagos. If you are in Lagos, come and check by yourself. But the thing is that I think I affected that list on Tuesday or Monday last week. So, but I don't want to answer you either yes or no, so that you will not see your name there later and you say, it's Oluseyi that told me that my name is not there now. Yeah, he's punishing me for what the wrong, for the mistake he made. So don't let me tell you whether yes or no. If you are in Lagos, come and check by yourself. The notice board is by the side of our lab, the machines lab. Just ask for electrical machines lab. You will see the notice board there. Your names are pasted there. Open place. Nobody is stopping you from going there. That's why we even pasted it there so that you can access it at any time. So don't let me in any way tell you that your name is there or your name is not there.
All right, sir. Thank you, sir.
Yeah. If there's no other question, we want to close the meeting at this stage.
We appreciate it, sir. Thank you, sir.
Yeah, see you next week where we will go deep into this particular topic. So